Okay, so for today we are going to discuss paper 6.2 for May June 2021. Okay, so let us start the first question. Okay, so the first question they tell us that in a game there's a ball thrown and lands in one of the four slots. So we have four slots here labeled A, B, C, D. Okay, then Raju wished to test whether the probability that the ball will land on slot A is 1 over 4. Okay, so there are a few keywords here. So first you can see the keyword test. So means that probably it will be the hypothesis test question. Then we talk about, they give us the probability as well. The ball that will land in slot A is 1 over 4. So for this one, you can see that they focus on probability. And for this sentence, if I translate into a symbol form, it will be P equals to 1 over 4. Okay, so let's start with question number A. Okay, so they want us to state suitable noun and alternative hypothesis for Raju's test. Okay, so since from this sentence itself, we can write out this P equals to 1 over 4. So you see the equal sign here. Wherever we have anything with equal sign, we should put it under the noun hypothesis, and the alternative hypothesis will be the opposite meaning of it. So we are having P equals to 1 over 4 as our null hypothesis, and therefore for alternative hypothesis it will be not equals to 1 over 4. Alright, so it should be the complement of the null hypothesis. Okay, so according to this question, because our null hypothesis it is P equals to 1 over 4, and then in the question itself also they didn't mention which direction they want to test. They just want to test whether it's equals to 1 over 4. Therefore, the alternative hypothesis will be not equals to 1 over 4. So this question will give us 1 mark. All right, then now we proceed to the next part. Okay, so for the next part here, they give us some extra information. Okay, so the ball is thrown 100 times and it lands on slot A 15 times. Okay, so the 15 times will be the observed value that we are going to use it to calculate the p-value or maybe the critical value later. All right, so from here, the n is 100. Okay, and then lands on slot A. So that means later you want to use the p equals to 1 over 4 to do the testing. All right, so here they say use a suitable approximating. Okay, so again, highlight the keyword approximating. So very obvious, probably they want you to change the binomial become normal distribution to carry out the test. Okay, so the test will be at 2% significance level. Okay, so let us start. Okay, first step, we already have the null and alternative hypothesis. So to continue with the test, you need to identify the original distribution. So you're having 100 times. And also the probability of landing on A is 1 over 4. So from here, you should know that it belongs to binomial distribution originally. And if you double check the condition here for the N and P, okay, so this is N and this is P. Okay, so you can see that the M and the N is more than 30, which is large. And then NP is greater than 5. NQ is also greater than 5. And therefore, you should change it become normal distribution. Okay, so how to get the normal distribution? You take N multiply with P, you get 25. And also NPQ to get the variance, which is 75 over 4. Okay, so just a hint for you all here. Okay, so this one to get the n, to get the mean, it should be n multiply with p. To get the variance, it should be npq. All right. Okay, so this is how we change the distribution from binomial to normal distribution. Okay, then we want to continue with the test. After you change it become normal distribution, there are two methods that you can use. You can use the p-value method, or you can try to find out the critical value method. Okay, so for me, I will use the p-value method. Okay, because originally from binomial, usually we will use p-value. Okay, all right. So for binomial distribution, they are saying that 15 times. Okay, so you compare the 15 with the mean. So 15 is on the left of the mean. All right, so that means when you want to calculate the probability, the p-value, it should be x smaller equals to 15. Okay, because this is the two-tailed test, right? Therefore, when you want to decide the direction, when you want to calculate the critical value or maybe the p-value, you need to compare the observed value with the mean. So when the observed value is on the left-hand side, then the probability, the area that you want to find is towards the left. Okay, so you can see that it is x smaller equals to 15. Okay, this is for binomial. So to calculate the p-value, before that you need to do a continuity correction first, which is 15.5. Okay, so the reason that we need to change it we need to do this continuity correction is because of the change. The discrete random variable become continuous random variable. All right, so the continuity correction is needed. And after that, you can standardize it. So to standardize it, you take the value of x minus the mean divided by standard deviation. So standard deviation should be square root 75 over 4. Okay, and you will get the value z smaller than negative 2.194. Okay, and after that, you try to get the probability from the normal distribution table, which is 1 minus 0.9859, and you will get the answer 0.0141. So please take note that this is actually the p-value that I calculate. Okay, and if I want to compare, if I want to make a decision, okay, whether should I reject or accept the null hypothesis, you have to compare your p-value with the alpha. Okay, so again, let us have a look for the alpha. This is two-tailed test. So if two-tailed test, that means one side will be 1%. Okay, on left-hand side, and then right-hand side will be 1%. Okay, for the significance level. So this one is on the left, right? So you should compare this p-value with the alpha for one side, which is alpha equals to 0.01. So p-value is greater than alpha, which is 0.01, or you can try to imagine that we are having this area, which is 0.01, and the 0.0141 is actually more than the 0.01. So the purple color is 0.141, 0.14, sorry, the purple color area, okay, is more than 0.01. And if you look at this line, the value of the area, it actually falls outside the rejection region. Okay, so from here, you should know that we actually do not reject because it falls outside the rejection region. Therefore, the conclusion for this question will be we do not reject the null hypothesis. Okay, so what is the conclusion for this one when we do not reject the null hypothesis? Okay, it means that there's no enough evidence to show that the probability that the ball will land in slot A is different from 1 over 4. Okay, so this is our conclusion here. All right, so in our steps, you need to make sure that you show a few important steps here. To me, the first one is this, okay? And then you must show them also, okay, your p-value, okay? Then the method that you get the p-value, and then you compare it with alpha and also the conclusion. All right, so this is how we answer the question number 1. Okay, so now we discuss question number 2. They give us a random variable x that has the distribution of binomial with all these parameters. Okay, so you should know that 400 should be n and 0.01 should be the p. Okay, so they want you to find the variance for 4x plus 2. Okay, so before you can find the variance for x plus 2, first I think we need to get the value for variance x first. Okay, so how can you get the value for variance x? All right, so the formula from a binomial distribution, variance x should be np multiplied with q. So it should be 400 multiplied with 0.01 and also multiply with 0.99. Okay, then from here you should be able to get the answer, which is the 3.96. Okay, so now I want to bring this value into our calculation for part A. Okay, so if I'm having variance for x plus 2, it is equals to, so 4 is a multiple for x, right? Multiplication with the x. So when you want to take out from the variance, you should square it. So it becomes 4 square multiply with variance x. And then plus variance 2. Variance 2, variance, that means it is a variance with a constant number, then you always get a 0. So you have 4 square multiply with 3.96, the value of variance x that you calculate just now. And from here you will be able to get the value for this variance, which is 63.4. It should be 63.36, or you can write in the fraction form, which is 1584 over 25, or you can actually rephrase it into a 3 significant figure answer. Okay, so this is how we get the variance for x plus 2. Okay, then we proceed to part number B. Okay, they want you to state an appropriate approximating distribution for x, giving the values of any parameters, and justifies your choice of approximating distribution. Okay, so when you're having binomial, okay, with these parameters 400 and 0.01, okay, if you check for the value of n, so you can see that n is large, okay, where n is greater than 50, right? Okay, so your p, okay, so p is 0.01, and if you multiply n times p equals to 400 multiply with 0.01, which is equals to 4. So this is the reason that np smaller than 5. Okay, with these two conditions, okay, so first condition is n is large. Okay, the second condition is np is smaller than 5. By fulfilling these two conditions, right, you should know that binomial can be changed to Poisson distribution. So this is the reason, okay, the answer for justifying your choice of approximating distribution. Then since you already know that you can change it become Poisson, so the mean, the lambda is mean, right? So it will be 400 multiplied with 0.01, which is equals to 4. So the lambda is equals to 4. Okay, so this is the approximating distribution for x now. Okay, then now we continue to the next part. Okay, so for the next part, part number B, they want you to use your approximating distribution to find this probability. Alright, so since I already have Poisson distribution with lambda 4, to calculate the probability for x between 2 until 5. Okay, so the formula will be E negative lambda. Lambda will be your 4 here. Okay, then we start from x equals to 2 lah. So x equals to 2 means lambda square divided by 2 factorial plus lambda power 3 divided by 3 factorial, lambda power 4 divided by 4 factorial, and also lambda power 5 divided by 5 factorial. Okay, so we should stop at 5 because they only want us to include the value for x equals to 5. Alright, so from here, if you just press the calculator, you should be able to get the answer, and I will correct it to 3 significant figure, which is 0.694. Okay, so question number 3, they give us a diagram. Okay, then this is about the random variable x that takes the values in the range of from 1 to p. Okay, and p is a constant. So the graph of the probability density function of x is shown in the diagram. So this is actually the PDF for x. Okay, so by using this PDF, they actually want you to show that p equals to 2. Okay, so you should know first of all, you should know that for our discrete random variable, the continuous random variable, all right, when you're having a graph like this, it actually means that the area under the graph should be equals to 1. So the area under the graph will be this triangle here. Okay, the area of this triangle is equals to 1. Okay, but we need to know what is the formula for the area of triangle. So the area of triangle is you need the base. This is the base, right? So what is the value for the base? It will be p minus 1. Okay, and then the height also to get the area of triangle. So the height is p. Okay, so you should know that area of triangle or area under the graph is equals to 1. So to get this area of triangle, it will be half multiply with base multiply with height, and it is equals to 1. So you're having p squared minus p minus 2 equals to 0. So from here, you get a quadratic equation in terms of p. Therefore, you need to try to rephrase it, or maybe you have to factorize it to get the answer for the p. So from here, you will see that our p value will be p equals to 2 and also p equals to -1. So which is the correct answer in your opinion? So again, if you refer back to the graph here, you can see that p should be a value on the right hand side of 1. So very obvious this is a wrong answer. So we will ignore the answer for p equals to -1, and our p is equals to 2. So from here, you can show that what they want us to show. All right, okay. Then now we need to go to part number 2. Okay, so for part number B, they want us to calculate the mean for the expected value of the x. Okay, so to get the expected value of the x in this case, generally you need to know what is the function for this line first. Okay, we need to know what's the function for this line. Okay, after that only you can use it to do the integration and get the mean, or you can get the expected value later after you get the equation of this line. All right, so to get the equation of this straight line, what should we do is like, it is quite simple because this is a straight line equation. So by using the 2 points here, for this point, it will be P and P, which is 2 and 2, the coordinate. And then for this point itself, it should be 1 and 0. Okay, so now by having these 2 points, you can actually try to find out the gradient for the line, and after that you can form the equation of the line. Okay, so this is our direction. Okay, so I will start to write out the steps here. Okay, to get the gradient of the line, okay, so we have 2 points here, right? 1 0 and also the 2 2. To get the gradient, it should be 2 minus 0 divided by 2 minus 1, which is equals to 2. Okay, and then to get the y, you can use any point. I'm using the first point here. All right, so y minus 0 equals to mx minus 1. So your equation for the y will be 2x minus 2, or you can assume that this is your fx, 2x minus 2. Okay, then now you will be starting to find out the expected value for x. So to find the expected value of x, you need to integrate the whole function, which is from 1 until 2, or from 1 until p. Okay, 1 until 2. And then you need to multiply the x with the original function fx. Okay, so this is how we find out the um, expected value of x. Okay, all right. Then now continue from this integration. So before you integrate it, you need to apply a little bit of the integration technique that you learned before. Okay, I will multiply the x into the function first, then only I will start the integration. So it will become something like this after the integration. Okay, then after that you just substitute the value into the integrated function. Okay, so if you substitute 2, you have 16 over 3 minus 4. And after that, you substitute the 1, and you will get 2 over 3 minus 1. Okay, then from here, you simplify everything, and the answer for the expected value of x will be 5 over 3. Okay, so this will be our answer. Okay, so we come to question number 4. Right, so we are having the Wendy's journey to work with 3 parts here. Okay, and all these 3 parts are normally distributed. Okay, then they want you to find the mean and variance for the total time. So total time means what is the mean and variance if you add all the time, okay, consists of the 3 parts here for Wendy's journey. Okay, so to get the mean, first of all, it is expected value. Okay, so everything is normally distributed lah. So you just add all the mean together, which is 15 plus 32 plus 8.6, and you will see that it is equals to 55.6. Okay, and variance. So for variance, we are talking about the total time. So total means that you add. So variance also, you just add all of them together, which is 1.1 square plus 3.5 square plus 1.2 square, and it is equals to 14.9. Okay, so this question is quite straightforward. Okay, then now we continue to part number B. So if Wendy's journey takes more than 60 meters, then she's late for work. So they want us to find the probability that on a randomly chosen day, Wendy will be late for work. Okay, so you need to know that because of our every single part of the journey, right, they are normally distributed. So the total time for the whole journey will be also normally distributed. Okay, so we are going to find the probability. So the probability of becoming late means what? Means that the total time. So I assume that the total time is the x. Okay, so x is more than 60. Okay, so more than 60 means that she's late to work. Okay, since it is a normally distributed variable, therefore you need to standardize it, become z, which is 60 minus the mean. So the mean we calculate in part 1 just now, which is 55.6. Okay, divided by standard deviation. So the standard deviation will be 14.9 square root. Okay, then from here you get the value z greater than 1.140. And from the normal distribution table, you take 1 minus 0.8729. And therefore you get the answer, which is 1271. Or you can rephrase it to 3 significant figure, which is 0.127. Alright, so this is our answer in part B. Okay, then now let us continue to the next part, part C. Okay, so for part C, find the probability that the mean of Wendy's journey time over 15 randomly chosen days will be less than 54.5. Okay, so for this whole question here, there's a very important keyword, which is this one, mean of the journey's time. Okay, the keyword is the mean. So when you see the mean height, mean weight, mean length, mean time, all these belongs to sampling distribution. Okay, so which means that sampling distribution means that you need to find the distribution for the sample mean. Right. So X bar will be normally distributed also because the population is originally normally distributed. What is the mean? So the mean will follow the population mean, which is 55.6. Okay, and then the variance for the sample mean will be the original population variance, which is 14.9, and you need to divide it by the sample size, which is 15. So our sample size here is 15 in this case. Okay, then if I rephrase it nicely, then I will get 149 over 150. Okay, so this is a distribution for the sampling, for the sample mean. Okay, all right. Then now, if you look at the question again, they are asking for the probability that the mean, so the mean means sample mean, is less than 54.5. Okay, so again, the sample mean here is normally distributed. Therefore, to calculate the probability, you need to standardize it. So minus the mean again, then divided by the standard deviation for sample mean. So it will be square root 149 over 150. Okay, and from here, get the value for Z, which is negative 1.104. Then from the normal distribution table, you should get 1 minus 8651. And from here, you'll get 0.1349, or you should be able to get 0.135. Okay, so this is how we answer question number 4. Okay, so now we come to question number 5. Okay, so they are talking about the time in minutes spent by customer at a particular gym has this distribution. So again, this is important, so I highlight it. It is normally distributed. Okay, then in the past, the value of mu has been 42.4. So this is originally the value for mu. And then following the installation of some new equipment and the management wish to test whether the value of mu has changed. Right. So the keyword here for the alternative hypothesis is has changed or not changed. So again, please take note that this word change actually didn't tell us in which direction. They didn't tell us whether is it increase or decrease. So it can be meant for both direction. Okay. Right. So we start with question number 8. State what is the meant by type 1 error in this context. Okay, so for type 1 error, it means that reject the null hypothesis when null hypothesis is true. Okay, so what is your null hypothesis? So your null hypothesis, very obvious, it should be mu equals to 42.4. Okay, then whether the mu has changed or not, okay, the has changed is actually your alternative hypothesis. Okay, so we reject the null hypothesis means what? Means that we conclude that the mu or the mean time or the mu, all right, here has changed because we reject the null hypothesis, right? So it means that the conclusion will be we conclude that the mean time has changed, although it is not changed. Okay, so although mu has not changed. All right, so that's the meaning for type 1 error in the context of the question. Okay, then now we continue to part B. Okay, so for part B, they have mean time for a sample of 20 customers is found to be 45.6. Okay, so first you need to know that this 45.6 is taken from a sample of 20 customers. So this is actually the sample mean for this sample. Okay, and it will be the value that we use to calculate the test statistic later lah. Right, so test at the 2.5 significance level whether the value of mu has changed. Okay, so let us start with the test now. All right, so first you need to write out the null and alternative hypothesis. The null hypothesis should be mu equals to 42.4 and mu not equals to 42.4 because of the keyword change in the question just now. All right, you can see the keyword here. So didn't mention any direction for the change. So it should belongs to both direction, which is not equals to. Okay, then the next step is you need to calculate the test statistics. For me, I will calculate the test statistics. Okay, so to get the test statistics, the formula is Z equals to sample mean minus the population mean. So the population mean should be 42.4 divided by standard deviation. So the standard deviation that we get just now is this one, 38.2. Okay, so we want the standard deviation, so it should be square root of 38.2 over square root n. So the n will be 20. Okay, so this is how we calculate the test statistics. Okay, and what is the value for the test statistic here? So z is equals to 2.315. Okay, so now to decide whether we should accept or reject the null hypothesis, we need to use the test statistic and compare it with the critical value. So test statistics is equals to 2.315, and we want to know what is our critical value. Okay, so to get the critical value, you need to use the normal distribution table, of course. All right, and before that, maybe you need to know what is the significance level for this case. Okay. All right, so since they want us to run the test at 2.5% of the significance level, and this is a two-tailed test, therefore we are having two rejection area. So this is the first rejection area, and this is the second rejection area. So the total area for both should be 2.5%, which means that this will be 0.0125, and this is also 0.0125. So that when you total these two areas up, it will become 2.5. Okay, all right, then now to get the critical value, since our test statistic is a positive value here, which means we want to calculate this critical value. All right, so to calculate this critical value, you need to use the area that is on the left hand side of this whole area. Okay, so this highlighted area, it should be 1 minus 0.0125. So which is 1 minus 0.0125, you should get 0.9875. Which means that to get this critical value, you need to look at the Z value for 0.9875. Okay, so I already cut out a part of the normal distribution table. I'm looking for 0.9875 from this part, the standard part here. Okay, so if you're looking for 0.9875, I think it is not hard for you to look for it. Okay, and what is the critical value that you can get? It will be 2.24. Okay, all right, so our critical value is equals to 2.24. Okay, then now I want to continue with my test. Okay, so I compare the test statistic with the critical value. So the critical value is equals to 2.24, and if you compare them, you can see that test statistics is more than the critical value. Okay, the more than means what? Means that 2.315 falls under the rejection region. Okay, all right, so from here I think the conclusion can be quite clear. Okay, so this should be the conclusion. We should reject the null hypothesis, and there's enough evidence to show that the mean time span has changed. Okay, all right, so this is what we have for question number 5. Okay, so we continued with question number 6. All right, so they give us the height of a random sample of 100 fully grown animals, and then these are the summarized data, okay, that we have. Okay, so first part, they want us to find the unbiased estimator of the population mean and variance. Okay, so for this question, generally, it is very, very straightforward. When you see the unbiased estimates for mean and variance, then these are the formulas that you should use. Okay, the unbiased estimators. All right, okay, so because here we are having the H, right? So for me, I will just write it out as the mean. Okay, so for first part, to calculate the mean, it is very straightforward. It is summation of H divided by the N. So you will get 75.7 as the mean. Unbiased estimation for mean. Okay, then now you want to get the unbiased estimation for variance. All right, so according to the formula here, sorry. Okay, so according to the formula, you can see that there are two here. So we are using the second one. Okay, according to the data that we get, this is a more suitable formula that we can use. Okay, so the unbiased estimated variance will be equals to 1 over n minus 1, which is 99, and then summation of h square 588050 minus the 7570 square divided by 100. Okay, then again by just pressing the calculator, then you should get 15001 over 99, or you can change it to 3 significant figure, which is 152. All right, so this is the unbiased estimated variance. Okay, so we done the part 1, which is very, very straightforward. Okay, then now we will continue to part number B. Okay, so for part number B, they want you to calculate a 99% confidence interval. Okay, so for 99% confidence interval, 99% confidence interval for the mean, the formula will be x minus mean, x minus z, then you take standard deviation over square root n. So the upper limit is sample mean plus z, then sigma over square root n. So this is actually the formula for 99% confidence interval. Okay, and then you substitute in all the value here. So 75.7 minus the z for 99% will be 2.576. Okay, then what is the sigma? So sigma will be the value that you calculate just now from the unbiased estimated variance. So please take note that you should use back the original value. Okay, the 152 is the adjusted value to 3 significant figures, so you should avoid this one. So you should use back the original value. Okay, then divided by the n. So the n here will be 100. Okay, then the same thing happen for the upper limit. Okay, so if you're asking how can we get the z here, how can I know that it is 2.576? All right, so you need to find out from a normal distribution table. Okay, by looking at it is quite similar to find out the critical value lah. So since it is 99% confidence interval, so that means on the left hand side and also the right hand side, you have some value here, okay, and you have to make sure that the center part here is 99%. So if let's say left and right hand side should be balanced out, then this one will be 0.05, this one will be 0.05 or 9 or 5%. Wait, no, it should be 0.005. Okay, then this one is 0.005. Then this one, the center part here will be 0.99. Okay, so that you add up, it is equals to 1. Okay, so the Z value is actually this one. So to find the Z value, the critical value, you should look for the whole area below this critical value. Okay, so you should look for 0.995 from the normal distribution table, and you can get the value for Z. Okay. All right, then after that, you just press calculator, then see what is the value that we get here. So into three significant figure, it should be 72.5 and also 78.9. All right, okay. So this is how we calculate the confidence interval. And next one, the part C. Okay, for part C, what they want us to get. Okay, so we have 4 random samples were taken, and a 99% confidence interval for the population was found for each sample. So every single sample here, we actually form a 99% confidence interval. Okay, they want us to find that all 4 of these confidence interval contain the true value of mu. Okay, so first of all, you should know that what is the meaning for 99% confidence interval. For any single confidence interval with 99%, okay, for this value, it means that the probability that the confidence interval contain mu is equals to 99% or 0.99. Okay, all right, so now please imagine that you are having four random sample of 4 confidence interval, and every of them contains the true value of mu. So what will be the probability? So which means that the first confidence interval contain the mu is 0.99. The second confidence interval that contains the mu also 0.99. The third one also the same. And also the fourth one also the same. So in short, it will be 0.99 power 4. And the probability should be equals to 0.961. Okay, so at first you need to know what is the meaning of the 99% confidence interval. Okay. Okay, so now we come to the very last question for this paper. Okay, so customer arrived at a particular shop at random times, and it has been found that the mean number who arrived during a 5-minute interval is 2.1. Okay, so to me, this is an important keyword here, 5-minute interval. Okay, so when they give you the mean in a certain interval, all right, then generally this is Poisson distributed. So you can see that this is the mean in a certain interval, right? So this is a Poisson distribution. Okay, so they want us to find the probability that exactly 4 customers arrive during a 10-minute interval. Okay, so when they want us to calculate the probability for 10 minutes interval, right, you need to adjust the mean according to the match interval. We are having 2.1 for 5 minutes interval. Therefore, the mean for 10-minute interval will be 2.1 multiplied with 2. It should be double up, right? Because the interval is 2 times longer. Therefore, the mean should be 2 times also. All right, so it will be 4.2. So your lambda now is 4.2. Okay, they want us to calculate the probability for x equals to 4. Okay, the formula will be E negative lambda, the lambda power 4 divided by 4 factorial. Okay, then just press calculator, then you will get 0.914. Oh, sorry, 194. Okay, then now we continue to part number B. Okay, for part number B, find the probability that at least 4 customers arrive during the 20-minute interval. So again, it still belongs to Poisson distribution, but again, you need to adjust the mean. So it should be 2.1 multiplied with 4 because 20-minute interval is 4 times of the 5 minutes interval. Alright, so the new mean that I get is 8.4. And the probability that they want us to calculate is x greater equals to 4. Okay, so for Poisson distribution, the value of x can be until infinity. Okay, any positive integer, infinity. So when you are having the question like x greater equals to 4, you have to take 1 minus. Alright, so 1 minus x smaller than 4. Okay, so 1 minus x smaller than 4 means that start from x equals to 0 until 3. So e negative lambda, sorry, the lambda is 8.4 now. So 1 minus e negative lambda. When x equals to 0, it is always 1. When x equals to 1, it is always the lambda. When x equals to 2, it will be lambda squared divided by 2 factorial. And x equals to 3 will be 8.4, the lambda power 3 divided by 3 factorial. So from our formula here, it didn't include the 4. I didn't want to minus the 4, so I will stop at x equals to 3. Okay, so for this question also the same. When you try to press calculator and correct it to 3 significant figure, this is the answer 0.968. Okay, then now we will continue to the last part, part number C. Okay, so for part number C, use a suitable approximating distribution to find the probability. So again, I think you can see the keyword approximating distribution. To find the probability that fewer than 400 customers arrive during a 2-hour interval. Okay, so again, the same thing happened here. We need to calculate the mean for 2-hour interval. So it should be 2.1 multiplied with 24. We are having 24 5-minute interval in 2 hours. Okay, so you should take 2.1 multiplied with 24, then you get 50.4. Okay, when we are having the lambda, which is more than 15, generally we should change it become normal distribution. Okay, so you can see that our lambda here is already more than 15. Okay, therefore I will change it become normal distribution, which also fulfills the request of the question. All right, then the lambda here, the first value for normal is mean, the second value for normal is variance, and both have the same value because for Poisson distribution, both mean and variance are having the same value. All right, then now they want us to calculate the probability for fewer than 40 customers. Fewer means did not include. Okay, no equal sign. So x smaller than 40. When you change from Poisson, this is a discrete random variable, to normal, this is continuous random variable, you need to do the continuity correction. So for continuity correction of smaller than 40, it will become 39.5. Okay, and then you're having z smaller than 39.5 minus the mean. So mean is 50.4 divided by standard deviation, which is square root of 50.4. Okay, then from here you will get the value z smaller than negative 1.535. Okay, then again you need to find out the value, like the probability value from the table, from the normal distribution table. It should be 1 minus 0.9376, and eventually you will get 0.0624. Okay, all right, so here we completed the whole paper 6.2. All right, so thank you very much.